You're welcome to solving right angle triangles. In the next about 9 video clips, we'll be looking at how to solve a right angle triangle using basically two tools, the Pythagoras Theorem and trigonometrical ratios. But first, what is a right angle triangle? As you can see on the screen, a right angle triangle is any triangle that has one of its angles to be 90 degrees. Once any of the angles in a triangle is 90 degrees, it simply means that triangle is a right angle triangle. How do I solve a right angle triangle? In solving the right angle triangle, questions will arise where we'll be asked to find the length of any of the three sides or any of the two other angles other than the angle that is 90 degrees. To do this, two tools are available. One is the Pythagoras Theorem, and the second one is using the trigonometrical relation between the sides, popularly referred to as the SOHCAHTOA. First, we look at Pythagoras Theorem. The Pythagoras Theorem states that given any right angle triangle, that the square of the hypotenuse is equal to the sum of the squares of the other two sides. And the question then arises, which of these sides is the hypotenuse? The hypotenuse side, let me change the color of my marker to black. The hypotenuse side actually is the side, in this case AB, the side that is facing the right angle. Here I have a right angle there. By right angle will mean the angle that is 90 degrees. The side that is facing that right angle is what? Is the hypotenuse. So I can label here that my side AB is what? The hypotenuse. The other two sides are simply referred to as what? Other adjacent sides. But we won't be using those terms for now. Let's just focus on the hypotenuse. Some people say that the hypotenuse is the longest side. Of course, it ends up being the longest side since it's facing the largest angle, being 90 degrees. So let's write out Pythagoras Theorem in an arithmetic form. The rule says that the square of the hypotenuse, on the screen there, you will agree with me that C will be the square, will be our hypotenuse. I'm changing my marker, please. My pen to white. That means C square, the square of the hypotenuse, is equal to the sum of the squares of the adjacent sides or the other two sides. So I take A square and I take B square. Those are the other two sides we have there. Please, let's take note of the convention we are using here. You can see the side labeled small letter C is facing angle C, which is the uppercase letter, that's capital. Small letter A is the length of the side facing angle A, and small letter B is the length of the side facing angle B. The angles are indicated with uppercase, that is capital letters, while the sides are indicated with small or lowercase letters. Let's look at the next slide. Here we have it stated, Pythagoras Theorem, C squared is equals to A squared plus B squared. The hypotenuse square is equals to the sum of the squares of the other two sides. Here is an example. Let's apply Pythagoras in solving this problem. In the figure below, we are asked to find the value of y. Now looking at triangle ABC here, we can see that two sides have been provided, but the length of one side AC has not been given. And looking at the triangle carefully, we can see that side is facing the right angle. Obviously, this is a right angle triangle. And we can apply Pythagoras Theorem quickly by saying the side AC, which is the hypotenuse right now, square, is equal to the sum of the squares of the other two sides. Let me take here as AB and take the other side as BC. Of course, you will agree with me. I can say that means this is y square. That's my AC. My AB is 3 centimeters, so that's 3 centimeters square. Please pardon me, we didn't put our square there. Plus 4 square. And that gives us 9 plus 16, which is what? 25. So y square is 25. What is y? Y is therefore straightforward, the square root of 25, which gives us 5 centimeters. So in this case, the value of the side labeled y, the length is 5 centimeters. Take note that first we have to identify what kind of triangle it is. It's a right angle triangle, as you can see, a right angle there. Next, we are trying to identify, where is the hypotenuse? The hypotenuse is supposed to face the right angle, and immediately we notice that our y is what? The hypotenuse. Then we establish there that the hypotenuse square is equal to what? The sum of the squares of the other two sides. Let's move further. That's a summary of what we've just done, written out, well typed out from there. You have there y square equals to 3 square plus 4 square. I think we are okay with that. Let's advance. Again, we have another triangle on the board. Again, it's what? A right angle triangle. We are asked to solve for the length of the side labeled x. So we are looking for x. If I look at this triangle PQR, I can see that the hypotenuse is the side labeled RQ, which has been provided as 13. So if I say, okay, let me apply Pythagoras here, I can say using Pythagoras. Using what? Pythagoras. Why am I doing that? Because I can see that this is a right angle triangle, and Pythagoras theorem can handle this very well. RQ, which is my hypotenuse, please always identify that first, square, is equal to, the rule says, the sum of the squares, not the square of the sum, the squares of the other two sides. The other two sides are PQ and then RPR, okay? RQ is given as 13, so that's 13 square. PQ is given as 12, so that's 12 square. Again, I've forgotten this, please. Thank you. Plus PR, which is x, and x happens to be the value that we are looking for. 13 square is 169, and 12 square is 144, plus what? X square. Rearranging here, I can transfer 144 to the left hand side and it becomes minus 144, and we have x square remaining on the right hand side. 169 minus 144, you will agree, will give me 25, and this is x square. Of course, we have no more space, but let's just jump there. If x square is 25, I'm sure you are all screaming that this is 5. Yes, x will be equal to the square root of what? Of 25. And that gives us 5 centimeters again. Let's write this out more neatly. There we are. You can see that the side with the value 13 happens to be the hypotenuse. So we have the hypotenuse square there equals to the squares, or the sum of the squares of the other two sides. And then we proceed down and we obtain x as 5 centimeters. We'll take our last example for this first video clip. Remember, we are solving right angle triangle, and the first method we are using is the Pythagoras theorem. Let's get something more engaging. Wow. Here we have something that looks like a right angle triangle. Let me say it that way. In the actual sense, we have two right angle triangles embedded in this diagram. Let's put there. That's the right angle. Alright, this is refusing this. That's the right angle. I can see a right angle triangle if I call this point there, and there. That's one right angle triangle. I can see another one again if I take up here, there, and to this other end. That's another right angle triangle. So I'll take them one after the other. We are asked to find the values of m and n. Since I can see two right angle triangles embedded in this diagram, I'll start from the innermost one, since I can see that two of the lengths have been provided. Let's draw that out. Here we are. I've labeled the top as A, then BC. Here we see we have the hypotenuse already provided, so we have no problem there. We have one other side given to us, that's the side AB. Here is our hypotenuse. So I can establish again there that AC, which is the hypotenuse, square, is equal to what? AB square. What are we supposed to do here? Remember, it's the sum of the squares of the other two sides. And then BC square. Of course, from this, we can easily get our M. AC is 10, so that's 10 square. AB is 8, so we have 8 square. And BC, we do not know, so that's M square. So we are looking for BC, which is labeled M. 10 square is 100. 8 square is 64 plus M square. Transfer 64 to the left hand side. We have 100 minus 64 is equal to M square. 100 minus 64 is what? 36 M square. Of course, you can write this as M square equals to 64, and then M will be the square root of 64, and we agree that this is 8. Again, this is centimeters, 8 centimeters. Please take notes that once you can identify your right angle triangle, quickly identify which of the sides is the hypotenuse, and then develop your quadratic equation. So that was our right angle there. There. And of course, we had it at B. Let's continue now. Now that we know M, we can consider the bigger right angle triangle there, the one that would involve both M and N. If I can find M plus N, then I'll be able to subtract M from that and get my N. Please do not fall into the trap of taking this, and this as a right angle triangle, because of course it is not. So do not apply Pythagoras theorem there, because Pythagoras theorem can only be applied to what? A right angle triangle. Rather, we take this. That's the conclusion to the first one. Sorry, the summary to the first. Now, that's it. So rather, we look at the bigger triangle this way, and we can label it as ABD. The first point there, that's it here. The second point, that's our B. And then the most extreme there, which means our BD is MN. Our BD is therefore what? Sorry, M plus N. And as you can see, only BD is not known. So if I can find BD, which is M plus N, automatically I'll be able to get my N. Look at what we have here, that BD is what? M plus N. If I subtract M from BD by transferring M to the left hand side, that will give me my N, which is the objective. We have already obtained M as 6. So let's set out. Again, this is a right angle triangle. We've agreed that angle B is 90 degrees. Where is our hypotenuse? Oh, straightforward. I can see that AD is the hypotenuse. So you quickly put that down, that AD square is equal to what? AB square plus BD square. Plus BD square. AD is 17. So that's 17 square is equal to 8 square plus BD square. So first of all, we'll try to get our BD. Then once BD is out, that's all. 17 square. Let's write this neatly. There. So that's it. 17 square is 289. So that's it there. Our hypotenuse square is equal to the sum of the square of the other two sides. And then a square is 64 plus bd squares. Transferring your 64 to the left hand side here, we have 289 minus 64, giving us our bd square, and that gives us 225 equals to bd square. And bd, you will agree, will be the square root of 225, which is 15. Now that we know that bd is 15, what is n? We know that n will be what? bd minus m, as we already stated earlier. BD is 15 minus m, which we obtained as 6. So 15 minus 6, that gives us 9, which means n is 9 centimeters. Let's write this out neatly. That's it there. BD minus m is equal to n. And then n is equal to what? 15 minus 6, which gives us 9. So that's it there and there. That's it for our first video clip on solving right angle triangle. Let's take some more example in the next video clip.